Hi everyone! In this video we will describe and create basic probability distributions. Assume we take 3 fair coins and flip them simultaneously. Let x be the number of coins out of the 3 that land on heads. Construct a table showing the probability distribution of x. The first thing we need to find is all of the different ways our 3 coins can land. This will give us our sample space, and we can do it 2 different ways. The first way is I have 3 coins, and each side of the coin there are 2 for each of them. Multiplying these together gives us 8. That tells us we have a sample size of 8. However, I really like making a probability tree. The probability tree gives us the entire combination of all the options of how we flip our coins. So the first thing we do is the first coin can be flipped and we get a head or a tail. The second coin has a combination off of each of these with either a head or a tail for the second coin for the combination of the head or the tail of the first coin. The third coin flips, and it can also be a head or a tail in combination with all of the previous heads or tails. And then we follow our probability tree to write out all of the different combinations we can get. The first one is heads, heads, heads. So we have a combination of all 3 coins being a head. Then we continue in our probability head, head, tail. So we have the option of a head, head, tail. Then we have the other option. We've completed the third one here, so we are going to move down for the second one to head, tail, head. Then we have heads, tails, and this option is tails. Now we've completed this one, and because this doesn't go to any more, and neither does this one, we can move to the next, which is tail, head, head. Then we go tail, head, tail. And now that's all done here. So we're going to move to the next one, tail, tail, head. And the last one, tail, tail, tail. We have 4 different options for these 3 coins to flip, and we're looking for the event that it lands on heads. So we have the option of having no heads whatsoever, 1 head, 2, or all 3 coins are showing a head. The 3 coins showing a head are here. The 3 coins that are showing a tail are here, so there are no heads. And in between those, we have the option of 1 or 2 heads. So here I have 2 heads, 2 heads, and 2 heads. And then I have 1 head, 1 head, and 1 head. So let's fill in the rest of our probability distribution. The probability of having no heads occurs here, and we know that we have 8 different combinations. We could also count these as well, which are 8 different combinations. So we have 1 time out of the 8 for 1 out of 8 for 0 heads. Then for 1 head, we have 1, 2, 3. So we have 3 out of 8 where we get the probability of 1 head. For 2 heads, we have 1, 2, 3. So again, we have 3 out of 8. And the last one is 3 heads, which only occurs here. So we have 1 out of 8. Let's verify that we correctly created the probability distribution. The first thing we need to verify is that the probability of every event here, so the probability of event X, is between 0 and 1 inclusive, meaning they could be 0 or 1. And we have 1/8, 3/8, 3/8, and 1/8. Those are all between 0 and 1. So that checks off. Now the second part is that the sum of all the probabilities should equal 1. So let's add our 1/8 plus 3/8 plus 3/8 plus 1/8. When we add fractions, we add the numerator if the denominators are a common denominator. So we're going to add 1 plus 3, which is 4, plus another 3, which is 7, plus one more, which is 8. So we get 8 out of 8. 8 divided by 8 simplifies to be 1. We've now completed both requirements for the probability distribution, and we're all done.